Let's take a look at another type of motion. Now in Chapter 2, we looked at the motion of an object which was thrown up and then comes back down again. While the ball is in the air, the motion is free fall, as we saw in Chapter 2. But now we're going to consider this. Suppose I throw the ball not straight up in the air, but throw it at an angle, and it moves sideways in a parabolic arc. As it does that, that's a type of motion we call projectile motion. And when the ball is in the air, there's only one force that applies, and the force is gravity. But now, it's not just moving up and down, it's moving sideways as well. And that adds complication, and it's a complication that we can analyze by using vectors. And to do that, we're going to head outside. Let's look at a practical case of projectile motion, shooting a basket. When you shoot a basket, you launch a ball at an angle, and it flies through the air in a parabolic arc and lands in the basket. But now let's consider the motion of the basketball. We'll make a motion diagram as we've done before. We'll mark successive positions of the ball. Now we're going to take the difference in the velocity vectors for successive positions. And if we do that, we get the acceleration. And you can see the acceleration is directed straight down. And it doesn't matter which pair of points we take, the acceleration is always pointed straight down. So now, let's consider the motion of the basketball in two parts. We're going to take the initial velocity, we're going to break it into two components, a horizontal component and a vertical component. Now, after she lets go of the basketball and it flies through the air, let's think about what happens to the horizontal velocity and the vertical velocity. We're going to ask you questions about those in turn. Consider the horizontal motion of the basketball. You know something about the acceleration. So given that, what is going to happen to the magnitude of the horizontal velocity after she lets go of the ball? We'll give you some choices. And in fact, there's no component of the acceleration in the horizontal axis. And so the velocity just continues exactly the same from moment to moment. So the horizontal motion is uniform motion. And so we end up with successive horizontal positions that are spaced at equal intervals. But now, let's consider the vertical motion. Let's look at the vertical components of the motion. And if we consider the difference between successive velocities for the vertical motion, we get an acceleration vector which points down. But here's a question for you. What is the magnitude of that acceleration vector? What's its magnitude? We'll give you some choices. Well, the vertical motion is just free fall. And that's not a surprise because we know the ball's in the air, the only force that's acting is gravity. And so the acceleration is just a free fall acceleration, and the vertical motion is just free fall. The horizontal motion is uniform motion. The vertical motion is free fall. So it's two motions which we can treat independently, but when we analyze problems, we have to treat them together.